Scientists at Crown Research Institute, Scion, are working with aquaculture farm Moana, New Zealand, to produce a 3D printed bioplastic containing Paua shell. The new technology is making it possible to add value to what was largely a biomass waste stream.
The idea here is to generate value to a bio-based resource, like in this case, Paua shells. And Paua shells is actually exported or given to offshore processors, and we've got the opportunity to make much more out of it here in New Zealand. It was really through a number of conversations and exploratory discussions we have with a number of representatives of primary sectors. So we're always looking at opportunities to add value to biomass side streams. And this is one opportunity to potentially broaden it out for more than just Paua, but also other seashells, obviously. It's part of the bigger push for bioeconomy, where the utilization of biomass for more than just food and feed, so really bio-based products, fuel, chemicals. We're happy to look into broader primary sector side streams and potentially make value-added products out of it. For us, it is a part of the whole sustainability. So Scion invests a lot of effort into the broader bioeconomy, which is obviously an important part for keeping New Zealand prosperous and innovative. So this is a part of it, of the broader manufacturing and bioproduct strategy. In Europe, the bioeconomy now employs about 22 million people. And interestingly, they are quite often employed in regional or rural areas, coastal areas. So it's small and medium enterprises, so actually perfect for New Zealand. And it's also perfect to really combine the economic growth, but still preserving the environment and the natural resources. We've now proven the concept. We've shown, yes, we can incorporate it into filaments, into bioplastics. And the next step is to reach out to understand with other parts of the value chain, can we use other feedstock, are compounders or producers interested in utilizing it, but then also working on products and further applications. We see the value can be in two areas. One is obviously the shell in itself has interesting mechanical properties, but much more we are interested in capturing that beauty and the iridescence that Paua has, and how we can make that and get this into the bio-based filaments. International consumers and more consumers, especially the millennium generation, is really picking up on the sustainability and the social aspects of products. And there is a number of studies out there that brands and products that get this story right and the credentials right have doubled the amount of sales. Also with packaging, it is important to show and highlight these credentials.
My role here is 3D printing expert, so I'm working on the formulation that contains Paua shells and then make sure that they're appropriate for 3D printing. Here I have a biocomposite that contains Paua shells. We want something which is biodegradable, and we are trying to get away from petroleum-based resources. So we want to make some plastic items which are biosourced, and the Paua shell is also an amazing biocomposite that we want to integrate into our filaments. What we are measuring are the mechanical properties of filaments. So we make a wide range of filaments and then we test them, we do the mechanical analysis, and then we're trying to see if it has any influence, any improvement over the bioplastic on its own. And then also we want to improve the appearance, trying to make something which is really looking like a Paua shell.
I'm a chemist, so I'm more involved in the chemistry side of things. That means figuring out what the material we are using is made of. This gives valuable information on its reactivity, what it can be mixed with, what it can react with, what is allowed to do with this material, and what we can do. Paua is mostly made out of calcium carbonate, and this calcium carbonate is in the shape of crystals in the shell, and these crystals plates are arranged and stacked and they are linked together by a biopolymer. And this is this configuration which gives the shell its incredible toughness, but also its iridescence and its colors. We first start with a Paua shell, which is clean. We ground it, we sieve it, so we obtain a powder, homogeneous. Then we mix it with a bioplastic, and we extrude them together to obtain a filament like this, which can be 3D printed directly.
The Paua on its own is a really amazing biocomposite, and then we tried to integrate it as a toughener into our composite to improve the mechanical properties, but also we wanted to improve the appearance of our composites to give it striking beauty into our items. The Paua shell has a multi-structure, and we're trying to understand at what level we need to integrate it into a composite to make sure that we get the best properties. We're hoping that within 18 months we will be able to give industry a value propositions, and at the moment we see that we have connected some dots with the industries and the interest is present. So now for us the next step is to improve our technology and make sure that we can demonstrate that to further partners that they can invest in our technology.
This program was made with funding from New Zealand On Air.